OK. I guess we should start. Hello, everyone. Welcome, Kotlin Conf. And let's start presentation. My name Konstantin. I work in JetBrains in a Compose Multiplatform team. And all we know that Kotlin and Compose Multiplatform works on every modern platform. And we can run our applications. And we have a screen. We have a canvas on the screen. And there we can render our Compose application. What could be simpler, right? But the problem lies in some user expectations. And to explain that, let's imagine the simple and, I think, typical situation. Our business wants some application from us with the three typical screens. First screen is authorization. We need to provide some login password inputs. Next screen, a list of some items. Of course, we need pagination of the screen and refresh our items. And third screen, just full information of the item. And for example, we need to zoom in and zoom out of the maybe photo of the item. And it is easy to imagine how it should work and look like on Android, right? Because everyone uses mobile device, and typically Kotlin works good on Android, and everyone knows how to implement such screens on Android. And regarding iPhone, there is no big differences, right? Because users expect the same application in the same form factor, maybe with small features like, I don't know, overscroll effect and maybe a little bit different navigation gestures. Regarding desktop, it's an absolutely different story. For example, how to implement authorization screen. Maybe we need to use dialog for the authorization, or maybe we can use full screen for the authorization input, or maybe we could run window for that. The same about list of some items. How should look like? Maybe it's and how we should refresh, because we need to have this feature on the screen. Maybe we need to draw special button for that. Maybe we can use some hotkeys for that. And how to see item info on the screen. Maybe we can use list detail layout in our application. Maybe we have to start new screen, and then the question how to go back. Maybe we can run new window for that, or maybe even dialog. And we don't know how to zoom, because on MacBooks we have a pinch to zoom gesture, but on other system maybe it's not so typical. And even more, for the desktop, user expectations are to have scroll bars for every scrollable content, and mouse hover states, etc., etc. And we cannot describe exact expectations on the desktop because they don't exist. By historical reasons, almost all desktop applications work differently. Let's say we decided to go with this design. It doesn't matter. And when we want to port or run our application in a web browser, we can say, oh, it's just like a desktop, but in a browser. Let's reuse the same design there. But then we have to check user expectations in the web applications. And first of all, a browser provides feature like full refresh on the page. We have to support it somehow because every user knows how to use it. And what about navigation? Because navigation in the browser, it's a standard thing. You can go back and forward. For the list item screen, usually users expect text selection, right? Because it's so typical thing like select text and go to Google it. Or even text search, because browser provides that feature under the hood. And of course, every browser usually supports user plugins. And more. For example, there is not only one browser, but three different browser engines. We have a different operation system there with a slightly different behavior of browsers. And of course, to form factors for the web applications. It can be run on desktop or your mobile. And even more, the same application can be run or in a browser or like progressive web application or even wrap it in Electron to run as a desktop. So in our team, we try to support everything what we want, and our mission is to provide a way to run existing application in a browser, reuse as much as possible between platforms, of course provide faster updates with no publishing overhead, and behave to native apps on mobile platforms. And of course satisfy general user expectations. That's what I want to share with you, how we try satisfy these expectations, and I want to start with the context menus. Let's take a look what is our expectation when we use a context menu. It's quite easy. When we maybe select something on the page, click on right mouse button, we expect to see some menu with actions. But it depends on the context where you click your mouse. If you click on a text or if you click on the image, there will be a different context menu. Even more, there is web applications is not standard HTML page, but which is rendered on canvas like Google Documents or Google Maps, and they have own context menus. So we understand there are two different types of menus, standard and native menus and custom menus. So what should we select for the Compose multi-platform in web? We decided to go with the custom menus because, first of all, it's fully customizable, and second, it's common behavior between platforms. That's what I said before. And how it looks like? It's just a simple pop-up, right, with some actions related to the content you clicked on, and it's a bit dynamic. For example, if you already select all text, there is no need to show you select all item. But what's the difficulties with that? Let's say you copy text from the, I don't know, other application and try to put it in our web application and want to click on a paste action. What will happen then? Browser will ask you, is it possible to read system clipboard or not? Why? Because of security, right? And to support this feature, we had to re-implement all of the API of clipboard to be asynchronous, because on the other platforms, it's quite easy to do that synchronously. And do you know how the same menu looks like in a Safari browser? Like that small blue paste world in the center of the screen. And to support menus on a mobile web factor, it should be look a bit different. It should be like a toolbar. And since it's customizable, when you add some custom elements, it will be scrollable left and right. And if you click on a past there will be quite descriptive dialogue on Safari. But how it looks like in Firefox, again, it looks like absolutely not clear, just a word in the center of the screen. Anyway, I tried to show you that even simple feature, what we know how to work, not so simple when we try to implement it. Another thing, at the moment we are in a beta, and we planning stable release soon, and we want to polish everything what we want, what we can and what we want. And there was one my personal pain point on the web. This is scrolling. When I compare scrolling in a web application written in Compose multi-platform and standard HTML application, I noticed that the scroll is much slower. And I decided to find the reason for that. And surprisingly, it was just a simple one-line issue in our code. We forgot to multiply on a screen dimension. And I was so happy about that I fixed the issue that I posted the results in a Kotlin lang Slack. And yeah, first impression was like, oh, it became much better. But then the same user said that, oh, sorry, but on Android it works not natural. So again, it's all about expectations. Of course, because I fixed the issue only for the desktop browser, not for the mobile. So I decided to fix a mobile scrolling as well. First thing, when we try to fix something, we have to have some reproducible sample to see the difference before and after the fix. And happy for us, Compose works and as Android application and as a web application in browser. So I was able to make UI test and run the same, absolutely the same UI test on an Android native application and on a Compose multi-platform in web. So on the left side, you will see native behavior. On the right phone, you will see how it worked in a browser. I hope it, yeah. I wouldn't say this is what we expected from the so simple thing like scrolling in the applications. And maybe you notice it, and I did it as well. When we see the problem with the scroll in the web, we see a lot of these guys, ripple effects on our items. So that was first thing I tried to find why and fix it. And of course, I found a simple bug in our source code. We just forgot to properly configure early tap detection in the web, and we put 0 there instead of 150 milliseconds. And after that small and easy fix, the scrolls became absolutely identical between Android native applications, I mean native in the Kotlin, and Compose for web. But I know that every application, in my opinion, of course, usually contains images. And if we try to show images in our scrolls, it will work again not as we expected there. Usually we don't do image processing by your own. Usually we use some libraries. And there is quite popular library Coil. And in my example, I used Coil, and I decided to check what is going on, why it's so bad. Somewhere in the Coil, in the version before 3.4, there was method decode image. The method gets the bytes of the image file and converts it to the SKIA bitmap to render on the screen. Right? Here the method, which is process your files to the bitmap, and this is quite heavy method, right? But the function is suspend function, and usually it's okay. We just run the function on dispatcher default, and it works perfectly on the different threads, and it shouldn't be our problem, right? Does it work on the web or not? Let's see on the browser debug tools. If you run official Coil sample and see to the flame graph, you will see that we have only one main thread in the browser, and we have a lot of these small yellow squares there. It means we skip the frames, and our UI, of course, junky. That's why we need to discuss multi-threading in browsers. I guess everyone have heard about web workers, some kind of multi-threading in browsers, right? Web workers just a simple means for web content to run scripts in background threads. And it works some kind of like actor models, right? We have a main thread, we have a web worker, and they pass messages between each other. So what we need to do, just make this heavy method make from image asynchronous, like decode image, decode bitmap, and put all the logic into web worker. There is no need to read this JavaScript code. but the main idea is that we get the message with the bytes of the file, then render the file on a off-screen canvas, get the pixels of the rendered file, and pass it back to the Compose application. But let's see a bit closely to this process. As an input, we have a Kotlin byte array, right? This is the bytes of our file. Then we pass it to the web worker. Web worker processes it, and we convert it back to the Skia bitmap. But the thing is that there are two different worlds, two different runtimes. Our Compose application works in a Wasm runtime, and Skia, of course, works as a Wasm binary. But the web worker lives in a JavaScript runtime. And it means that we have to cross the border between two worlds. And for us, it means that we have to, because Wasm runtime is fully isolated runtime, we need to pass objects with the copying between them. So we have to convert our Kotlin byte arrays to JavaScript array buffer and back from JavaScript array buffer to Skia bitmap. So by this picture, we see that it is not possible to avoid at least two copies of bytes in our program. Let's check that we do everything correct. When we get our bytes of the image, we have to convert to the JavaScript array and get its buffer, right? This is one copy. But then we send the message to the web worker, and if we get the documentation of web worker, we see the stop data passed between main page and web worker, not by the they are copied, not shared. So it means that we again, when we post our message to the web worker, we copy this array again. So two copies, not good. Let's take a look at the documentation on web workers. And we found there is such thing like transferable objects. This is exactly what we need. We need to transfer our array from the one world to another world without copies. So for that, we just have to add this transferable object to the end of the call post message. And that's what I did. And then I have only one copy when I go from the Kotlin world to the from the Wasm runtime to the JavaScript runtime, and the same on the way back from the web worker to the Wasm runtime. We have to put the transfer object in the post message. Good. And then we get this array in a processed image bytes bitmap back to the Kotlin world, and we have to convert it again to the Kotlin byte array. That's the method. That's another one copy, right? We have only two copies, right? But then we install the pixels to the Skia to render it. And by some reasons, Skia under the hood copies this array again. That's the problem. I found it in a flame graph, in a memory graph, etc. It would be awesome to solve the root of the problem and avoid Kotlin byte array in the process and copy raw JavaScript array buffer directly to the Skia runtime. And here I will show you some black undocumented magic. Let's say we need the function which copies our array buffer just directly to the Skia memory. First of all, we prepare empty data object inside the Skia. It's not copies, it's just empty prepared space in the Skia memory. Then we get the Skia memory, direct access. And finally, we just copy our JavaScript array buffer directly to the Skia memory, like in a good old times with the assembler. And after that, in a version 3.4, it was merged. And then, if you check the same official sample, we see that we have special worker to process images, and there is no skipped frames. Honestly, I was so happy about that. I was so happy that I started to play with every my pet project and scroll and scroll and scroll. And you know what? It was not good idea. I found the problems more. Yeah, and we have to go deeper. Scrolling part 2. I noticed when I scroll really fast and I do really, really short gestures on the screen, I see some problems. I see that sometimes when I do really, really fast flink on my screen, instead of scrolling to up, my scrolls starts to scroll down. Why? Again, I decided to make reproducible sample. I made this UI test. I just 40 times swipe on the screen, and I logged all input events on native Android application. And you see this perfect picture. This is 7 steps of my gesture, and it's exactly what I expected by the test, right? In the device.swipe method, last parameter is how many intermediate steps of your gesture should be provided to the application. But if I run the same application with logging input events in a browser, I'll see absolutely different picture. I see that there are not so many events printed on the screen. And I decided, oh, maybe it's unsolvable problem. Maybe because of we works in Wasm and Compose maybe too slow for the browsers, and it's not possible to solve it. But then I decided to make simple HTML application which just logs the same events in a browser, and I see absolutely the same picture. The reason is that just browsers send less events to the application. And this is fine because, you know, I don't know, Wikipedia works perfectly. It scrolls fast and with no problems. And I decided to find the reason inside our code base, inside Compose Multiplatform. And there is such class as velocity tracker. It gets all input events inside and makes parabola by them, and a tangent in the last point will be your output velocity of the scrolling. And it works perfectly, usually. In all the cases, we try to scroll our content, and it calculates how it should be scrolled when you remove your finger from the screen. But sometimes, in the case when then there are less than 3 points, it's just stop your scrolling. And sometimes when there are only 3 points, the parabola can be bended different direction, and your velocity will be to opposite direction. And that's what I decided to fix. And why it's not the problem for Android, for example? I already showed you Android tracks much more events on your screen, but in a browser, events not so packed, and we have less, and sometimes we have this problem with the velocity tracker. So the fix was quite easy. When I have only 3 or 2 points, I just get the first one, last one, and put special adjusted point in between to have a perfectly expected velocity in the output. So, and it works, it really works, you know. And again, I was happy about that. After that, I didn't see the problem with the different direction. But then I remembered that regular web application written in JavaScript and HTML, they don't have such problem. Every scroll works good. So I decided maybe I don't need this hack to fix the behavior. I need to check again our code base. How usually it works under the hood? Browser provides some pointer events to the application. We have to map it to internal representation as a Compose pointer event, and then Compose will work with that. And this mapping function looks like that. We get a browser event, get some data from inside, and put to the Compose stand. And you see this method. As a time millis of the event, I get the current time millis of the browser. It's not so noticeable, but if in the browser something blocks your main thread, it means that event will be mapped to the compose event a little bit later than it should be. And the picture of your parabola will be absolutely different. So again, one line fix, and we don't have such problems. So scrolling between 1.10 and 1.11, absolutely different. Okay, let's get back to the expectations, user expectations, and our compose multi-platform for web application. I already mentioned that in a browser, absolutely different expectation from navigation. In the classic web, when I read some article on Wikipedia and click on a huge logo on the top, I get back to the root screen, to the main screen, right? And then I'm able to click on the back button in my browser, and I will go back to the previously article in the Wikipedia. And then I can even click on the forward button and go back to the home screen, main screen, etc. And this is fine. This is what we expect by the web applications. And we call it chronological navigation. But how it works in a regular mobile applications, like, for example, classic Android, if I stay on the main screen of my application and I click on the back button, I expect that I will return to the launcher screen, right? No one expects that I will go to the previous article in the Wikipedia. And we call it hierarchical navigation because it depends on business logic of your application, on hierarchical of your screen. What should we choose for the compose for web? And someone can say, of course, this is the web application. We have to choose chronological navigation because this is what users expect there. But what to do if we migrate our current existing application from the Android to the web? How it should work there? And even more, there is progressive web application, which is web applications installed on your phone. And we want they behave like close to native and navigation too. Okay, so we can say that our default should be hierarchical navigation. But there are some problems as well. What we have to do with web-only applications in the desktop browsers? I think no one expects that when you click on a back button in a browser, you will go somewhere but not on the previous visited page. Or why does the forward button not work? Right? In mobile phones, we don't have a forward button, but browser has. And of course, site in a mobile browser works unusually in that case. And we don't know. I work close with the Google on Navigation 3, and we don't have yet a solution what should be default. But for now, I made my small library with both these cases and chronological and hierarchical navigation. So you can configure a library and it will work as you want. Let's summary. I showed you how we work with context menus, right? They are different on desktop, mobile, and we had to re-implement APIs to be async. For the scrolling, I fixed a few bugs, few maybe strange bugs in our code base, but anyway, I made some adjusted point inside the velocity tracker. To improve user expectations, I had to make pull request to the Coil image processing library, and I added web worker there, and of course, I made some black magic with the direct access to the linear WASM memory. And for the navigation 3, what I can say that work in progress, and there is a library you can try for now. And I have some small bonus for you. As a final of my talk, sometimes expectations are quite easy. We want that some things just should work in our applications. But sometimes when they don't, we are angry about that. And after the merge of this issue, you can follow that. It's already done. It already works. Maybe it will be merged today. Everything will work as you expect. Thank you, and don't forget to vote.